Good afternoon, everybody. Is everybody enjoying the fact that you're indoors and there's a beach about 300 yards away from us with your name on it? Thank you for being here and not out there, although I'm sure some of us will be out there at some point in this conference. My name's Tim. I am Director of Solution Engineering at Wowza. I tell my kids I'm the explainer. I explain as best as I can what our software does, what video workflows do to regular people. I'm not a developer, although I love to solve problems, and I'm sure some of you can relate to that. I want to pound out in about 20 minutes, and I think I can do it in less than 20 minutes. I want to talk about ultra-low latency streaming. I know that there was a creative title to this session, but really what it comes down to is how do we crack this ultra-low latency code? And I think we've been working on it for quite some time. With Flash kind of drifting off into the sunset, we're all trying to find ways to get video distributed fast. And I think some people are doing it better than others. I think Wowza is doing a pretty good job at it. And I just kind of want to have a conversation. Now, if you're listening to me and I'm going on and you have a question, raise your hand. I might call on you if my mind is clear and we could kind of segue a little bit, but we've only got 20 minutes, so I'm going to give it my best shot. So again, thank you for being here this afternoon. Latency, what is it? It's a noun. The amount of time between when a frame of video is captured and displayed. We call it glass to glass. I don't know who thought of that term, but it makes sense, doesn't it? There's a lens on the front of the camera, and there's a glass or a piece of plastic that looks like glass on a device. And the amount of time it takes for the light to hit that lens, go through the sensor, the encoder, distribute out, and get onto your device is ultimately the latency. And this is a typical live streaming workflow. This is Streaming Media West. I would be surprised if most of you don't have familiarity with this. Starts with a camera, goes into an encoder. If you don't know what an encoder is, there's some guys over here in the exhibit hall that would love to tell you all about them. It can be a software component. It can be a black box, which is plugged into a power supply and an Ethernet in most cases. And it takes the feed from the camera, which is like an HDMI or an SDI, and then gets it into an ingest and processing center. We call that a media server. There's all kinds of different flavors. The one I know the most about is Wowza because they pay my paycheck. And then it goes into distribution, which is commonly known as a CDN, so Content Delivery Network, and then it gets out for playback. So that's a typical live streaming workflow. We can do this. Most people, just standard out of the box, you push it through Akamai, even just push it through a local instance of a media server. I have Wowza running on my laptop, which unfortunately isn't able to work through HDMI this afternoon, so I'm using a different device. But I get about 30 seconds out of the box. That's with a 10-second chunk size standard spec with the Apple HLS. Now, low latency, it looks very much the same. You've got a camera, an encoder, it gets ingested, it gets distributed very differently. Wowza does it using our technology that's staged in different cloud environments. We have kind of a midgress and egress, and there are technologists that can speak much more authoritatively on how we design our architecture, but ultimately we're using our proven software in a cloud environment in order to get this information distributed very quickly. Some people do it with caching servers. Some people actually are doing low latency through Amazon S3. So there's no only one way. There's several different ways to get low latency out and distributed. We're doing it to scale, and I'll talk a little bit more about that in a couple of minutes. But the cool part about it is, and this is actually true, we can do it in less than 2 seconds. When we started testing this low latency product, more so about a year, maybe 9 months ago, I didn't hear this firsthand, but I did hear, through the water cooler conversations in our company, that some guy from Sydney sent an RTMP stream to AWS in San Jose, so up here in Northern California, and got it in less than 2 seconds from Sydney to California and back. I had a hard time believing that, honestly, but that's the claim. So it's exciting when it actually works. It's really cool to see how fast video can be distributed in the browser. It's all about interactivity. In my job, I told you that I tell my kids I'm the explainer. I get on the phone with folks who want to build the next gigantic, big, evil streaming corporation.com, and they don't always know what they need. And one of the first things I ask when they say low latency, I seriously ask them why. Why do you need are you sure you need low latency? What is latency to you? Because ultra low latency is cutting edge technology. This is something that's continuing to evolve. There's more codecs and there's more about this story that's going to be told. But right now, it's a challenging thing to do. We can do it. But if you can do it with Apple HLS in a more conventional, more stable workflow, I strongly suggest doing that. But in the case of auctions, esports, gambling, medical applications, sports, nobody wants to see on Twitter what happened 30 seconds from now. You want to be synced up. When there's a touchdown and one of your friends has got it on Facebook and you see comments about it, you want to see that happening right now, not 30 seconds ago. I thought about auctions. You know, a few years ago, I got a call from a couple of cowboys in Alberta, Canada. And, you know, we all work in the tech business for the most part, and we're always thinking about these really cool companies we work with. Yeah, I was working with, you know, such and such broadcaster. And, you know, we love to talk about, like, these really cool workflows. These are a couple of cowboys that I pictured smelled like cows. And they had that vibe, you know, and they're kind of like, yeah, we want to do a cattle auction, right? And I ended up having this really cool conversation. They need low latency. They have a cattle auction that's live. They're selling cattle live. That's a great, albeit a very simple, probably very small scale use case, but it applies. I mean, there are a lot of opportunities for low latency to make sense. Social media, e-commerce, government, I won't belabor this too much, but there are very the game shows, the HQs, the really cool, you know, interactive stuff happening now. Just a little bit of background. There's a few ways that we can categorize this. Number one, you've got common HTTP latencies today. You know, I love what I do. I really enjoy working with the Wowza streaming engine software. And sometimes people don't understand that HTTP latency isn't necessarily our fault. HTTP was designed for graphics and images. You know, those older guys like me that have been around, we remember how slow things happened over dial-up. And remember when the internet and the browsers, you know, there was Netscape and there was those older technologies and they could barely render an image, right? That's the same protocol, except somebody figured it out, Apple, to do it over HTTP. So there is an inherent latency because you're watching a chunk of video right after a chunk of video, back to back to back to back. It's super stable, but it does create a latency problem. So you get 45 seconds out of the box with standard, reliable, good old-fashioned Apple HLS or MPEG Dash. There's ways to do it where you can squeeze it down. OTTs have it inside an 18-second range. This might be something you would get from a cable operator. Maybe you have a set-top box that's using a more aggressive protocol. And then, you know, there's the and we did this when we were starting to get into low latency business. We had a whole bunch of Wowza employees figure out the latency on their cable box at home. We had a way of comparing it to OTA versus, you know, what they were seeing on Spectrum, on DirecTV, on Comcast, on, you know, whatever. And it's about a 5-second latency to live. So even watching satellite television, cable television, it's about 5 seconds. So it's not, you know, latency isn't something new. And then you move over into the lower latency category where you're dealing with user-generated content, live streams, game streaming, esports. So the farther you go to the right, the more challenging, the more cutting edge, the more difficult it is for the networks, more difficult it is for the clients, but you're getting into more real-time protocol. You know, you guys probably use Zoom, GoToMeeting, BlueJeans, you know, those type of clients. Those are cutting edge. That is near real-time communication. I don't have the demo because my Apple device doesn't like talking to this video processor, but what I did have was, and I'm just going to tell you about it, I had 4 images on the screen, and one image was, it was like a multi-view. One image was our Wowza low latency, ultra low latency platform. The other one was good old-fashioned RTMP, which many of us can't say goodbye to. We're still in love with RTMP, right? But it's gone. And then there was standard HLS, and then accelerated HLS is when you take those 10-second chunks and you break them down. And so I could wave at my webcam, and you would see fast, kind of fast, and then like 20 seconds later, and then you'd see like 30 seconds later, you'd see a wave. So that's me and my best attempt at narrating my really cool tech demo. So anyway, it's phenomenal to see how the different latencies compare. So let's go back a little bit in time. You remember click here to download Real Player? Click here to download Windows Media Player. I did my first stream in 1999. Yes, I know. That's awesome. On Real Server. There's Flash, QuickTime. Those are some of the old protocols, but are super fast. RTSP, for example, I believe that's what Real was using at the time. And there are people who are building mobile applications to scale using RTSP because it is low latency. It doesn't have a lot of bells and whistles on it, but some of these old legacy video streaming protocols actually are quite remarkably fast. And then, of course, there's today the HTTP streaming protocols. That's the old Apple logo, by the way, which I think is pretty cool. There was Adobe, San Jose Streaming, Microsoft Smooth Streaming, which was another phenomenal protocol. And then, of course, there's MPEG-Dash. This gives you 8 to 10 seconds. So that's where we've been. Where we are today, I'm watching time closely. Out of the box, you get a 10-second chunk. And I just kind of tried to describe a couple minutes ago how when you're watching a video, you're watching 10 seconds, and then your player's downloading the next 10 seconds, and then it gets into that second chunk, and then the next chunk arrives, and that's functionally how it works. Well, we can change that. You get into a media server, and you can say, don't do a 10-second chunk, do a half-second chunk or a 1-second chunk. And then the media server gets super busy, the network gets super busy, but you end up actually with better latency. You end up with 8 to 10 seconds instead of 30 to 45 seconds. And you might remember earlier when I shake down people who think they want low latency, sometimes tuned, optimized, super HLS, whatever you want to call it, sometimes that's plenty good. And again, if you can get by and you don't need that ultra right now super low latency, HTTP modified is fantastic. Just a couple other codecs and protocols that are on the horizon. A couple that I'm familiar with is SRT, Secure Reliable Transport. It's actually pretty cool. It uses UDP, and you can do a little bit of error correction. It's low latency. WebRTC, which is supported by Wowza and many, many others. Very low latency, browser-based protocol. The nice thing about WebRTC is it can pick up your webcam and mic in the browser, and you can not have flash, but you can still get that low latency stream. Fragmented MP4, DALs, SLDP. There are, as I mentioned earlier, there are a lot of opportunities on the horizon in the protocol codec business for low latency. I think it's going to continue to progress. I think a year from now, we're probably going to see some very compelling additional options for low latency than what we have today. Real quick, I've got a couple minutes. I'd love you to, if you're interested, check out Wowza Streaming Cloud. We have an ultra-low latency CDN. It actually works to scale. We're claiming sub 3-second latency glass to glass. This is something that a developer can get a hold of and use an API and build it into an application. You can also, if you're interested, use our Wowza Streaming Cloud web user interface, meaning you give us your credit card, you subscribe, you send us your RTMP stream, and you've got global low latency sub 3 seconds. We actually can do that. We want you to take advantage of our service. I'm going to blow through this because I really want to be respectful of time. Again, real similar workflow. You can source it with a media server like Wowza, GoCoder, which is an SDK. So a mobile app developer can use the camera and the mic, get a stream out, have it distributed low latency, IP cameras. We can play it back in the mobile on GoCoder SDK. Because that's another thing I've kind of not mentioned, is it's really hard to play back low latency. HTTP can play pretty much anywhere. But low latency, we're using WebSockets, or we're using our SDK to play it back. You have to have a little bit of finesse in getting that just right. And I'd love to cover it in detail. I'm not going to have enough time in session, but that's one of the greatest challenges of the low latency itself. With Wowza, we have a player builder. We make it really easy to translate the URL for the low latency playback, plug it into some code, and you can drop it into an HTML page. And much like what you see with JW Player, BitMove, and Theo Player, where you can get this piece of code you drop in, we've got the same type of workflow. Without low latency, again, we've had a lot of these left to right linear descriptions, camera encoder, transcoder, CDN. With low latency, we're doing both. So you request the API, you request a low latency stream through our API. We provide an HLS option, and we also provide a low latency option in the same workflow. So it actually works really well because you're going to encounter issues with playing back ultra low latency in some scenarios. So you can just pivot and use an HLS in the same stream. It's reliable, ultra-low latency, it's secure. We've got a global network. We have analytics that are available, very developer-focused product. I am proud and I'm excited about what Wowza's done with ultra-low latency. Would love for you guys to check it out. I'm coming up on time here, so this is what we're going to do. We're going to talk about how to get in your hands the $200 Amazon gift card that I know you're all here today skipping out on the beach to get your mitts on this guy right here. So I would like to ask the question, it's a very easy question. What is, am I doing that? Forgive me, I get excited. What is the standard latency time, or what's the expected latency time with Apple HLS? Yes, sir. You're not correct. Yes, sir. 30 seconds? You're the winner of the $200 Amazon gift card. Now, if you have any other questions about Wowza, there's two gentlemen over here. There's the guy who's wearing a sweatshirt in Southern California when it's 80 degrees out, Mr. Brad Wright. And the gentleman just to his left, Pete McIntosh, he's our technical marketing manager. My name's Tim Dougherty. I'm a solution engineer. Thank you.
Big round of applause for Tim.